We're going to work on 3 different types of applications of the solving a quadratic equation using factoring. So for my first one, we're looking at consecutive integer problems. The consecutive integer problem means that we're dealing with values that are consecutive integers, or in this case, consecutive odd integers, meaning if the first one's 3, the next one's 5. If the first one's 13, the next one's 15. The first one's 71, the next one's 73, etc. So odd integers. I'm going to let x represent my first integer. So wherever my first integer is, I know that my next integer is 2 more than that. Now how do I know that? Because when I was making my list before of 13 to 15, I noticed those were 2 apart. Or 71 to 73, I noticed those were 2 apart. That's where I got the plus 2. Because whatever I tell you the first one is, you're going to add 2 to that to get the next one. Well, I know that if I take the product of those, meaning I'm multiplying x, which is my first number, and x plus 2, which is my second number, if I take the product, I should get 35, because it says is, meaning equals, 35. Now this is great that we were able to write the equation, but I actually need to solve. And so when I need to solve, remember I need it to be set equal to 0, which means as great as this part is that it's already sort of factored, I need to get it out of parentheses to get x squared plus 2x equals 35. And then I need to move the 35 to the other side of the equal sign to get x squared plus 2x minus 35 equals 0. This is the question that I'm trying to solve. So now I'm going to look for numbers that multiply to 35 that subtract to 2, which would be x plus 7 and x minus 5. Remember, those aren't my answers. That's just the binomials that I've broken them into. To then solve or find the integers, I'm going to set x plus 7 equal to 0, which gives me negative 7. And I'm going to set x minus 5 equal to 0, which gives me positive 5. Now, are these two values, negative 7 and positive 5, consecutive odd integers? No, they're not. However, I know, because I said at the beginning, that whatever the first number is, if I add 2, I get the second integer. So if my first integer is negative 7, then 2 more than that would be negative 5. Are these consecutive odd integers? Yes. Do they multiply to 35? Yes. So that's one solution. Let's look at the other one. If my first value is 5, x plus 2 would be 5 plus 2, or 7. Are 5 and 7 consecutive odd integers? Yes. Do they multiply to 35? Yes, they do. So I have 2 different options in this case. For yours, a couple of things are different, so listen first and then pause it. This one we're looking for consecutive integers, so not consecutive odd, and also I want only the positive ones. So go ahead and press pause, try to set this one up and solve it yourself, and then press play to see how you did. Again, I would let x represent my first integer, but because this one is consecutive integers, it's not odd integers, which are 2 away, my second one would be x plus 1, so it's just the very next number would be my second integer. Now the product of them is 110, so x times x plus 1 equals 110, and I haven't dealt with the positive yet. I'm going to do that when I get to the end of the question. I'm, just like last time, going to distribute the x. And just like last time, I'm going to move the 110 to the opposite side to give me x squared plus x minus 110 equals 0. And then I'm going to factor. This would be x plus 11, x minus 10. And I'm going to solve those by setting them equal to 0. And that gives me negative 11 and positive 10. Well, at the beginning, it says they only want the positive integers. So even though I found the answer of negative 11, this question, we don't care about it. We only want the positive. So my two integers would be 10, and then whatever x plus 1 is. So of course x plus 1 would be 11. So my two consecutive positive integers would be 10 and 11.